Alisin natin ang siyensya, buksan ang pag-iisip. Tayo'y likas na scientist. Tayo na.
When we hear the word mathematics, most of the people would say that it sucks, frustrating, hard,
Oh, hell no!
and even would say that it's ugly without even knowing that mathematics is the fundamental tool used by the geniuses of the genius people to create things that no one would have thought possible. But this wouldn't be possible without our nature and its patterns. Nature's pattern. Many of us wouldn't know that it's as natural as the flowers, animal spots, or even snowflakes would give us and lead us to what we have today and on how we view our world. So for this vlog, we will be discussing a chapter of a book that contains a deep mathematical regularities that can be detected in natural forms or in our nature. Nature's Number by Ian Stewart. Ian Nicholas Stewart, FRS, CMath, FIMA, is a British mathematician and a popular science and science fiction writer who was born in 24th of September 1945. He is best known for his popular science writing, mainly on mathematical themes. His book, Nature's Numbers, was shortlisted for the 1996 Rowan Pauling Prize for Science Books. We will discuss the chapter 1 of his book, The Natural Order. Here, we'll be able to understand how nature's pattern opened us to how geniuses started, influenced their discoveries, and how nature's pattern, with the help of mathematical theories, impact our view of our universe. Johannes Kepler was a German astronomer, mathematician, astrologer, natural philosopher, and writer of music. So let's relate the laws of motion according to Newton to laws of planetary motion from Kepler. He observed objects in motion on surface of Earth, right? For a long time, and eventually he hypothesized that, well, wouldn't those same laws that govern the motion of objects on the surface of Earth, wouldn't they still work in outer space? Right? Wouldn't they still work in the heavens? And so he called this a connection, one universe. The prefix uni meaning one. There was a mini plague of sorts in London, the Great Plague of 1665. So Newton had to quarantine himself in his countryside home. So during those years, he refined Kepler's law of planetary motion. He applied math to those laws and actually showed that, yes, it's mathematically right. Newton supplied theory behind Kepler's observational data. But first, let's dig into the chapter 1 of the book's Nature's Number. However, guys, if you wanted to know more about the planetary motion, I will put the link in the description box. So now, let's ask Angela as he tackles fractals, chaos, and Fibonacci.
Hey, pretty amazing info Lai had shared to us about the two geniuses theories that have given a lot of contribution to all the knowledge we have today. So now we will proceed to the different type of pattern that our nature had, and to further understand the chapter 1 of the book by Ian Stewart about the nature's number. So let's go tackle it. Patterns. Patterns possesses utility as well as beauty. It can be recognized to different kinds of nature's pattern, as we are still identifying new kinds of pattern, as our universe has still a lot to discover. So, speaking of discovery, these are maybe not the latest but still new. And these are what we call fractals and chaos. So, let's talk about those two. Fractals are the terms made famous by the mathematician Benoit Mandelbrot, which is a new science of irregularity. It is a geometric shapes that repeat their structure on even ever finer scales, and the dynamic process that causes them known as chaos. Chaos, on the other hand, is a kind of apparent randomness whose origin are entirely deterministic. They are created by repeating on simple process over and over in an ongoing feedback loop. Driven by recursion, fractals are images of the dynamic systems, the pictures of chaos. As what Mr. Stewart mentioned in his book, it took us humanity a while to catch up with these new types of pattern, as it was only within the last 30 years as we humans become explicitly aware of this pretty interesting discovery, right? After the new types of pattern, let's tackle about the simplest of nature's pattern, which are numbers. However, according to Stewart, that this is stated in his book, numerology is the easiest, however, it is consequently the most dangerous method for finding patterns. Huh? It's kind of confusing, right? But it is easy because anybody can do it. Dangerous because for the same reason. So, the difficulty lies in distinguishing significant numerical patterns from accidental ones. And sometimes pattern seeking in numerology is that it generates millions of accidentals of each universal. But let's focus on things that we mostly see in our daily lives, but no idea that those part in nature's number. So let's go. As we observe our environment, we see patterns that are in sequence. This sequence, we call it Fibonacci effect or sequence. A Fibonacci sequence in nature, it appears in biological settings such as branching on trees, the arrangement of leaves on a stem, the fruit sprouts of a pineapple, the flowering of an artichoke, uncurling fern, and the arrangement of pine cones, and etc. But most fascinating and, according to Stewart, a curious pattern indeed occurs in petals of flowers. In nearly all flowers, the numbers of petals is one of the numbers that occur in a strange sequence, and these are definite pattern of numbers which each number is obtained by adding the previous two numbers together. For instance, 3, 5, 8, 13, 21, 34, 55, 89, and so on. Aside from that, we can also observe pattern in our human body parts. Also in animals, like for example, our arms and our legs. We people have 2 legs, cats have 4 legs, insects have 6, and spiders have 8. Starfish, on the other hand, have 5 arms, or 10, 11, or even 17, depending on the species. Aside from what I mentioned there, additional neurology patterns Stewart mentioned in his book, and for us to know it, Lisha will share it to us. Let's go!
So hello everyone, as Angelo discussed fractals, chaos, and Fibonacci, I will be the one discussing the geometric and the transversions part of the chapter 1. So to begin with, we all know that a general shape is a collection of dots and can be presented as a list of and pairs of numbers. But shapes, on the other hand, are typically better to be thought of as shapes, for it makes use of our powerful intuitive visual talent, and whereas listing pair of numbers can be left to various laborious activities. Until recently, the main shapes that appealed to mathematicians are very simple ones. So these are the squares, triangles, circles, hexagons, pentagons, spheres, cubes, spirals, cones, and so on. So as an example, we can make use of the rainbow, because we all know that a rainbow is made up of circles, and each circle represents different kind of colors. And even though we do not see it fully as a circle, only an arc, it is still considered as a shape in nature. So circles can also be seen in the ripples of water, the shape of the human eye, and the wings of a butterfly. Other examples of shapes in nature include the intricate web that the spider web makes, the shape of it, and the ring inside the trunk of the tree to determine how old it is or wide plantations of rice, sugar canes, or vegetables. On the dry land, there are also wave patterns. The huge ergs or sand oceans of the Arabian and Sahara deserts have the most stunningly geometric landscapes on the planet. These are called transverse dunes, and sand dunes occur even when the wind blows constantly in one direction. So the most basic pattern of sand dunes are called transverse dunes, and they look like much of ocean waves. And they line up in parallel straight rows at right angles to the prevailing wind direction. And the rows themselves can become wavy, which are known as barachnoid ridges. And they can also break off into a slew of shield-shaped barchan dunes. If the sand is slightly moist, there is a little vegetation to bind it together, then you may find parabolic dunes shaped like a U with a rounded end pointing at the direction of the wind. So these sometimes occur in clusters, and they resemble the teeth of a rake. If the wind direction is variable, other forms can become possible. For example, clusters of star-shaped dunes can form, each having several irregular arms radiating from a central peak. They arrange themselves in a random pattern of spots. So proceeding to the patterns in animals and movements, we have Therese Monares.
Hello mga Vebs! For today's video, I will be discussing about the Fibonacci sequence that are found in animals and nature. But before that, let's have a quick recap about Fibonacci sequence that was discussed by my fellow classmates before me. So, what is Fibonacci sequence? It is a series of numbers in which each number, known as Fibonacci number, is the sum of two preceding numbers, and the simplest is the series 1, 1, 2, 3, 5, 8, etc. Fun fact, it can be seen everywhere, and in fact, we are surrounded by different patterns of living and non-living things in life that represent the Fibonacci sequence. Patterns possesses utility and as well as beauty. Once we have learned to recognize the background pattern, exemptions suddenly stands out. In this part of today's video, we will be focusing on the Fibonacci sequence that can be found in patterns of animals and nature. Examples are provided. So the following pictures are pictures of my cat taken by me that resembles the Fibonacci pattern or sequence, and as you can see, the spiral shape-like pattern shows its similarity to the Fibonacci sequence. The white cat is named Mume, while the black one is named Bas Morgan. Next, our main focus here are the Fibonacci sequence in patterns of nature. Mother Nature has its own beauty, and its creation has been simple yet extravagant because of its pattern that correlates the Fibonacci sequence. One of the common and simple example that represents the pattern of Fibonacci sequence in nature is the flowers, especially the flowers that has 5 petals. Other examples are the wave patterns on land that are found in desert sand dunes, and how the trees' branches are growing. The picture provided shows. I hope you learned something, and coming up for the next discussion is the Fibonacci sequence that can be found in Patterns of Human Imagination by Jan Gavin.
Thank you. So, before I start to the another category, let me ask you a question. Does the clouds have its particular pattern? Or is it still be able to measure through a Fibonacci sequence? If you still cannot answer yet, let me steal the time in introducing the another category, which is human imagination.
Thales, Pythagoras, Euclid, Archimedes, Brahmagupta, Omar Khayyam, and Fibonacci are among the first pioneers in mathematical fields, and all of them start with their own kind of imagination of things. There are too many mathematical ideas that are clearly products of the human mind, and they are too useful to abandon merely because they are products of the human mind. As Albert Einstein said, the true sign of true intelligence is not about knowledge, but imagination. As we have already learned about Fibonacci sequence, let's go back to my question earlier about the clouds. The answer is yes. Clouds belong to a foam pattern because clouds are an object form of gases and liquid. So when you zoom into the tiny details of clouds, you may see a pattern of gases formed. Aside from clouds, another example of natural pattern in line with human imagination is a day and night pattern, which repeatedly after 24 hours. Another example is also the picture of the typhoon twirling, which is sometimes measured with a golden ratio. Mathematics is a science of patterns. We study to learn to think critically, logically, and creatively. From the standpoint of Fibonacci calculations, we study how we count patterns in its different forms. But it's not like that. We also learn to see the beauty of mathematics even in the simplest thing we have least observed. Indeed, we live in a universe of patterns. The universe is made up of galaxies, mountains, creatures, vehicles, and all manner of other things, each seemingly unique. Mathematical patterns and relationships have been developed and refined over the centuries, and the process of it is as vigorous and productive now as at any time in history.